To finish off the lesson, we're going to do an example. Determine the coordinates x and y and all the points that satisfy it on the unit circle. Normally, stated in other ways, we can say solve for theta. So we're going to solve for theta, and we're going to solve for theta where cosine theta is equal to 1/2. In other words, I'm looking for theta or thetas that have a cosine value of 1/2. I'm going to put two different scenarios. One where theta has to be between 0 and 360 degrees. And the next one where theta is between 0 and 2 pi. If I'm solving for theta, where cosine theta is equal to 1/2, and theta is restricted between 0 and 360 degrees, this implies that my solutions have to be in degrees. The first thing that I would do is I would draw my unit circle. I would, in my mind, ask myself, where is my cosine value 1/2? In other words, where is the x value 1/2? And now that's a really bad unit circle I just drew. I apologize. So here we are. There's a better unit circle. Where is my cosine 1/2? And really, I put these points very close to the y-axis because that is where my x value is 1/2. So in quadrant number 1 and quadrant number 4. And it is the two angles that are closest to the y-axis. And I'm getting 60 degrees and 300 degrees. Now, both of these are in the 60-degree angle family. All right, it's going to take some practice to get used to it, but let's move on to radians now. I'm going to solve for theta, where cosine theta is equal to 1/2. First thing first is I draw my unit circle. I identify where my cosine's 1/2, and that is in quadrant 2 or 1 and 4. And it is the angles that are closest to the y-axis. If you notice, my rationale hasn't changed at all. It's only the way that I've measured my angles. So theta, therefore, what are those angles that are closest to the y-axis that are special angles? That's pi over 3 family. And once you have your quadrant 1 angle, your quadrant 4 angle is going to be fairly straightforward because you know it's related to the pi over 3 family. And what is that angle that's related to the pi over 3 family in quadrant 4? 5 pi over 3. So there's my solutions in degrees. There's my solutions in radians. Let's move on. We're going to solve the sine of theta. So let's do the exact same thing here. We're going to actually make two different questions. We're going to solve sine theta is equal to negative root 3 over 2. In other words of saying that, there's a little bit of guidance. Where's the y-coordinate negative root 3 over 2? So I start this question off by drawing the unit circle. I then identify where I interpret this. Where is my y-coordinate negative root 3 over 2? It's right here and right here. My rationale for that is, so these angles hug the y-axis. So really, again, we're talking about the pi over 3 family, right? And it is, the question I have in my mind is, what angles are the closest that have a sine value of -1, that are really close to -1? Well, that's the root 3 or the pi over 3 family. So my solutions are, yikes, my apologies. I guess implicitly I've been solving it for radians, so I guess I'm looking at it in radians. So the pi over 3 family, the one in quadrant 3 is going to be 4 pi over 3. The one in quadrant number 4 is going to be 5 pi over 3. Now let us return to degrees. So I'm going to solve theta between 0 and 360 degrees. So again, I draw my unit circle. I am going to solve where is sine theta equal to negative root 3 over 2. Same as before. I ask myself, what are those two angles that are very close to negative 270, right? I don't want 270, I want those two special angles that are closest to that, because that's where the y value is negative root 3 over 2. So theta is equal to, so I guess I would be in the 60 degree angle family. That's what I'm talking about. So 180 plus 60, it's 240 degrees. And to get my quadrant 4, I guess I have to go 360 minus 60, which is 300 degrees. I hope this helps. Let us practice.